Okay, stats, let's finish 6.2. For the binomial experiment, so binomial random variable, if you can calculate things about it and probabilities, it means it should have a mean and it should have a standard deviation, so information about it. And the formulas are as follows. The mean for x is the number of trials times the probability of success. Standard deviation for x is the square root of the mean times the probability of failure, because NP is just the mean, or N times P times 1 minus P. According to Experian Automotive, 35% of all car-owning households have 3 or more cars. In a simple random sample of 400 car-owning households, determine the mean standard deviation of car-owning households that will have 3 or more cars. So the mean is easy. It's just N times P. In this case, N is 400. P is the number of cars that should succeed at having 3 cars. So that's 0.35, which is 140. Standard deviation of x is the square root of those two numbers multiplied together. There's a third number though, 1 minus p, so 1 minus 0.35 is 0.65, because it's 1 minus this thing. And then you put that in the calculator. And you get 9.54. So it's really about knowing these formulas and using them. It's not too bad. Now, down here it says use that table from the last page in the last video. Construct binomial probability histograms for n equals 8 and p equals 0.15, 0.5, and 0.85. You don't have to bother doing that. They're on the next page. So let's look at what they actually look like. Oh, these are slightly different, but that's fine. Well, let's look at a binomial probability histogram with n equals 25 and p equals 0.8. N equals 50 and p equals 0.8. You can look at the charts, by the way, on the completed notes. And n equals 70 and p equals 0.8. So what do we notice about these bars as n gets bigger? As n gets bigger, it starts to look, so this is a little rocky, but it looks kind of like a bell curve. But then it looks even more like a bell curve as n increases, and then it looks almost exactly like a bell curve. Why is this important? It says generally for a fixed probability of success, as the number of trials in a binomial experiment increases, the probability distribution becomes bell-shaped regardless of how the data is. It'll eventually become bell-shaped looking. As a general rule of thumb, if n times p times 1 minus p is greater than or equal to 10, then it should be approximately bell-shaped. Use the empirical rule to identify unusual observations in a binomial experiment. Now, it says 95% of all observations lie within 2 standard deviations. Anything outside of that is unusual. So according to Experian Automotive, 35% of all car-owning households have 3 or more cars. I should speak more eloquently, 35% of all car-owning households have 3 or more cars. A researcher believes this percentage is higher than the percentage reported by Experian Automotive. He conducts a simple random sample of 400 car-owning households and found 162 have 3 or more cars. Is this unusual? Let's first see, is it bell-shaped? N is 400. P is 0.35. 1 minus P is 0.65. When we multiply those all together, we get 91, which is definitely greater than or equal to 10, so it's good. It's going to be bell-shaped. It says find mu of x and standard deviation of x. We did this on a previous problem. If you go back 2 pages, we found the mean to be 140. And the standard deviation of x was 9.54 from 2 pages ago. Okay, so some people like to draw the distribution to visualize it. This is our distribution. We have our mean of 140. And each standard deviation to the side, I have to add 9.54, so it's 149.54. On the left side, subtract 9.54, that's 130.46. Add another 9.54, that would be 159.08. And this one becomes 120.92. So this is the middle 95%. Now, his data said he got 162, which is beyond the 159.08. So is 162 unusual? Yes, because it's outside 2 standard deviations. Only barely, though. So it's a little bit unusual. And this is the end of 6.2, which also means it's the end of the material for the next test. Now, I will probably have a partially proctored test next Monday over this stuff. We'll continue on to the next sections on Wednesday and Thursday. And I'll send out more details on what this will look like for a proctored test. And that's it for now.